Hey boys and girls, Mr. D here. In this video, we're going to be taking a look at how to solve systems of equations by using our substitution method. Again, when we talk about solving systems, some of us are getting confused here. When we talk about solving a system, we're simply finding out where a set of lines intersects, where they all meet, where they cross each other, okay? What point do they have in common? Or points in some situations, correct? So we worked on graphing, and now we're going to look at substitution. This is probably one of the most commonly used methods. It'll get us a very specific, exact answer as opposed to the graphing where sometimes we have to approximate it. So this is very useful, very important process that you'll use not only now, but really as you get into geometry, trigonometry, algebra 2, pre-calc, calculus, and so on. Substitution, very, very important concept. So let's take a look at it. First example here. Example 1. Solve system of equations by using substitution. Alright, so here's our rules and our guidelines, okay? So take a second and copy these down. You can press pause. Okay, hopefully you've got them down. Again, the first thing you have to do is get the variable alone. And if you look at these two equations, we've got the y alone in both of these already. So number 1, as far as I'm concerned here, step 1 is done. Okay, so let's take step 2 here. Substitute for that variable in the second equation. So again, we can choose either of these equations to plug in for. So essentially, let's just take this equation here. We know that y is the same thing as negative 2x plus 1. So we're going to take this, okay, and we'll plug it in for this y right here. Okay, so what we would end up with is something that looks like this. Negative 2x plus 1 equals 3x plus 6. Okay, so we've gotten the variable alone. Now we've substituted this variable into the other equation. So this step is done. Well, almost done. We've got to solve it. All right, let's solve it. All right, so let's solve for x here. We want to solve for x. We got x on the left side, x on the right side. Got to get them together. I'm going to move this x over to the right. So we got to go plus 2x because it's minus on the left side. So we'll do it to both sides. Okay. So here we've got 5x plus 6 on the right-hand side. On the left-hand side, we just have our positive 1 remaining. Got to get x all by itself. Let's subtract 6 both sides. Subtract 6, subtract 6. So we've got negative 5 equals 5x. Divide by 5, we know that x equals negative 1. Great. So now we're done with step 2 officially. Okay. Now let's go to step 3. We have to plug our numerical answer in to either equation, either of these equations, to get the other coordinate. Just so we can see our original first equation. So let's take, it does not matter which one. We choose the one that's easier, or looks easier. Both these are pretty simple and straightforward. I'm going to plug it into the second equation. So here we'll go y equals, and you can continue this straight down in your paper. I'll move it over to the right-hand side just for lack of space. 3 times negative 1 for x plus 6. 3 times negative 1 is negative 3 plus 6. Well, negative 3 plus 6, we should know, is positive 3. Alright, so y equals positive 3. Which means our point of intersection between these two lines is where x equals negative 1 and y equals 3. So our point of intersection, we'll put it in a different color here. We'll change it up. Negative 1, 3. Voila. There we go. Let's take a look at our second example here. Okay, and that's step 3. Take a look at our second example. And here's our same steps. Okay, same steps. Please take a moment and copy those down again. I want to really hammer home the fundamentals and the steps here. So pause the video and copy those down. Okay, hopefully you've got those down now. Now if you look at these two equations, in none of these equations do we have a variable all by itself. What is interesting here is, if you look at this term right here, this term has a coefficient of 1, where all these other terms do not. That gives me a hint that this is the variable I want to get alone. It's going to be a little bit easier to get this variable alone. It's going to be less work. It's going to be less steps involved. So if I get this variable alone, in order to do so, I have to move this 2y over. So it'd be x, right, plus 2y minus 2y, right? We'll take minus 2y from each side. That's what I'm saying here. Alright, so what we have is x equals negative 1 minus 2y. And we just leave it as that. We can't do anything else with that. As far as simplifying, these are not like terms. So, first step is done. We got the variable alone. Now we got to substitute this variable back into the second equation. Okay, so we've got to take this equation here, and we have to plug it back into this second equation for x. We're going to plug it right into here. Okay. So what we end up with, instead of it being 2 times x, it's 2 times negative 1 minus 2y. Okay. Minus 3y. Just copy the rest of the equation down as we see it, equals 12. Okay. Alright, so we got to continue solving for y here. The first thing we have to do here is we got to do our distributive property. That means we got to do 2 times negative 1 gets us negative 2. 2 times negative 2y will give us negative 4y. Okay. Equals 12. Alright, now, oh, sorry, I forgot something there. Sorry, guys. 4y. Oh, minus 3y equals 12. Let's fix that one up a little bit there. Alright. So y. So there we go. Negative 2 minus 4y. That's from our distributive property. Bring our minus 3y down. Equals 12. Combine our like terms. Negative 4, negative 3y. It's going to give us negative 7y. We have our negative 2 equals 12. Well, we've got to get y alone, so let's add 2 to both sides because it's being subtracted here. Plus 2, plus 2. Let's try and extend this page here. That's fine too. Okay, so just extended the page a little bit there. I have more room to work. So we added 2 to both sides. Now we got negative 7y equals 12 plus 2 here, so it's going to be positive 14. So y equals positive 2. Sorry, negative 2. Right, divide by negative 7. 14 divided by negative 7. Positive divided by negative gives us negative 2. Great, so now we've got step 2 done. Now we've got to plug our numerical answer back into either equation. Okay. So, again, think about which equation might be easier to plug it back into. I like the first equation. Again, it has less coefficients. I think it might be easier to work with. Sometimes when we guess here which one to plug it back into, we end up plugging into the wrong one, but that happens sometimes. It's not the end of the world. You'll get the right answer either way. Sometimes you just make a little more work for yourself. So x plus 2, and here's our y. So our y we know is equal to negative 2. Let me just copy the rest of the equation down as it is. Well, 2 times negative 2 is negative 4. I forgot my x here. Right, so x minus 4 equals negative 1. All right, and then just solve for x. We got to go plus 4 to both sides. And so x equals negative 1 plus 4, that gives positive 3. So our solution here is going to be 3, negative 2. So that point, when we say it's a solution, again, that's the point where these two lines intersect. All right, it's a solution to both these points. If we plugged 3 in for x and negative 2 in for y into either of these equations, they should all balance out and check out. Okay? Take a look here at one more example. This is a tough one. Please, I'd like you to write this one down on a separate sheet of paper and complete this one on your own. I'll collect this one tomorrow when we come into class. If you get it correct, I can put you up in the Wall of Fame. Okay, so let's take a look at this one, see if you can come up with this one on your own. And again, on a separate sheet of paper, please, on a separate sheet of paper, follow your same guidelines, same rules that you're doing before. Okay? Hope you found this helpful. This will be a good challenge problem for you guys. We'll see who gets it right. See you in class.